Okay, so in this video, let's understand what dropout is and how it helps prevent overfitting. So so when you have a very deep neural network, the thing is a very deep neural network is highly prone to overfitting because you have so many weights. You have tens of weights, you might have hundreds of weights and tens of layers. So by the time a different data point reaches the end, it can overfit. Because what is overfitting? Overfitting is basically a small change in your training data will result in a large change in your performance, right? So that's what overfitting is, and neural networks are highly prone to overfitting. So dropout is a technique that helps prevent overfitting in neural networks. Okay, so if you remember random forest, what did we do in random forest? Random forest was also is essentially a technique that reduces overfitting in decision trees, right? And you sample both columns and rows and in the random forest, and this leads to you know less overfitting by the model. So over here, what are you essentially doing? You're not taking the entire data set. You're taking parts by parts of the data set, and that leads to less overfitting. That leads to the model performing better. So what this basically means is that randomization of features leads to regularization, right? Randomization of features leads to regularization. Correct? And that's exactly what dropout does as well. Uh, it's Dropout is basically regularization, but for deep neural nets. So let's say you have a deep neural net. Let me just draw one over here, right? Change the color, and every neuron sends an input to every other neuron, right? That's a deep neural net, correct? Now, what does dropout do is that in any given iteration and in any given layer, randomly pick neurons and remove connections so that all outgoing and incoming connections are destroyed. Okay? So let me just draw this and explain what it is. Let's say that I choose a so when you choose a dropout level, you the number is between 0 and 1. Okay? It's called row and it's between 1 and 0. So if I choose row to be 0.3, okay, what I'm going to do is in every layer, I'm going to just switch off or I'm going to just cancel all the inputs and outputs from 30% of the neurons. So look, over here in this layer, I have three neurons, right? 30% of that is approximately one neuron. So randomly, I'm going to pick a neuron from this layer for every iteration, and I'm going to close all the inputs and outputs to that neuron. So let's say in the first layer, it's this one, in the second layer, it's this one. So what I'm going to do is all my inputs will not go into these two neurons, all right? Ultimately, my inputs will only be like this, okay? So this is what dropout is basically. Um, you randomly take neurons. If you first choose a dropout number or a dropout level, and you randomly take neurons and you in every layer, in every iteration, and you switch them off, all right? So if you think about it in a way, this is also similar to what we did in random forest, right? Randomization of features leads to regularization. Similarly, some we are randomly switching off some neurons over here, and that leads to regularization. So that is what uh, dropout is all about. It's a very simple idea. Now, obviously, the mathematical proof for this is a little more complicated, but I just want to draw, sort of an intuition from random forest of why dropout works in deep neural nets. So that's what dropout is. Now look, at train time we can do that. At train time we can switch neurons off, and we can basically prevent overfitting. But what do you do during test time? Because at test time you can't switch random neurons off, right? So what do you do at test time? You basically, if you have neurons, one, two, three, four, five, six, seven, you basically just take this. Yeah, so these are all your connections. This is during test, okay? This is during test. So look, if what you do is the value that you chose for your dropout, you just multiply all the weights with that value. So look, at train I had uh maybe I closed this one off. Okay, so I don't have a layer over here, right? This one's closed, it's switched off. So but I have all my weights over here, correct? These my weights are being trained here. So this is during train. So at test, what I'll do is I'll have all the neurons and I'll have all the connections, but I'll multiply all the weights W1, W2, W3. I'll multiply them with the dropout value P. Okay, so it'll be P into W1, P into W2, P into W3, and this will comprise of your weight vector. Okay, this is your weight vector. Sorry, not P, W. This is your weight vector. So that's how you use dropouts when you between train and test, because in the testing phase you can't randomly switch off neurons, right? And this P over here, the dropout rate, is generally a hyperparameter that you tune, and you tune it over multiple iterations to see what value of P performs best on your data set, right? So yeah, that's what dropout is all about.